Okay, so for this 22, they say they give us a system linear equation, or they give us a equation already here. So from here, we have to express this equation in the metric form, in the metric equation, where A represents the coefficient, X is the unknown, where X is the unknown, and then hence determine the metric A and B. So coefficient of x, y, z kita keluarkan 2, 4, 1, then 4, 3, 7, then 2, 1, 3, right? So our matrix unknown is x, y, z. So equals to our metric B here is 7, 7, 1, 1, 4, 48. Okay, so from here they say you have to determine, after you write in metric form, you have to determine what's your variable metric A and variable metric B. So from here we can know our metric A is this 2, 4, 1, 4, 3, 7, 2, 1, 3. Then metric B is 7, 7, 1, 1, 4, 48. Okay, so 2 marks only. So these 2 marks, just 1 mark for you writing in metric forms, 1 mark for us to identify which is the metric A label here, which is metric B label here. So after we get this, we can go for question B. They said from the A, we are going to obtain determinant A first. So this one have to answer first, then only we say hence. They say hence. Okay, use this of information to answer the B1, B2, B3. So first of all, I have to find out what is the this one, determinant of A. So I need to refer my metric A just now. I just denoted here. Just now my A is 2, 4, 1, 4, 3, 7, 2, 1, 3. So therefore, start doing our determinant A. It will be element 1, 1 minus 4, then plus 1. Then we start to close, do the minor 1, 1. Okay, minor 1, 1. We get to the answer of 3, 7, 1, 3. Okay, copy paste, in and out. The vertical one here is 4, 2, 4, 2. Okay, so do the cross multiplication, 9 minus 7 in bracket. So that's why that's the difference between this palang and bracket. Palang is determinant. Then 12 minus 14, and then 4 minus 6, which is equals to 10. Okay, so what is they say hence I have to use this answer lah. Determinant of A is 10. I have to find out what is our determinant of P if PA is equals to identity. So we are going to perform our properties here, properties of the determinant. So number 1, B number 1, when they say PA equals to identity, so means I determinant of them will equal to determinant of identity. So in the properties of determinant, when we have determinant PA, it will also equal to determinant of P times determinant of A. So determinant of identity. So we have to find out what is our determinant of P, where determinant of A we already found, which is 10, determinant of identity, which is 1. So determinant of P will equal to 1 over 10. So for B part, how about determinant of Q? If say the Q has this relationship, Q is equals to 2A and then these matrices transpose. So when we have determinant of Q, it equals to determinant of these 2 times this matrix A and transpose. So when we take out 2, because A is a 3 by 3 matrices, when we take out 2, when we times 2 means every row we will times 2. So when every row will times 2, for every row you take out, it will 2 to the power of 3. Because first row, second row, third row, 3 times determinant of A transpose. So determinant of A transpose will be equals to determinant of A. So that will get to this 80. Okay, so we can explain it using our notes here. So you can see what's the properties here. The first one, determinant of A is equals to A transpose, which we apply here. Determinant of A transpose equals to A. This is our first properties. Alright. So this one, element of column there's 0, determinant of 0. This one they didn't test us. They test us about this. If a certain row or certain column is multiplied by k, then we will times the determinant by k. So it will apply here because it said 2 times A. So this row, first row times 2, second row times 2, third row also times 2. So the determinant will times 2 times 2 times 2. It will go up 2 to the power of 3 because of this sentence. For certain row, for a row, when you multiply a k, so your determinant also need to times k. Alright, so that is our properties we're using here. And then we can see the last properties here. When you have matrix multiply, actually there can be determinant of A times determinant of B. So this is what we apply at here, PA. So matrix PA here. Okay, so that will be our concept. So we're looking at our marks here. The first mark is how we're going to find our determinant of A to get to the answer. Then we use our properties here. Properties of this AB equals to determinant A, determinant B, right? Then we get to find out what is our determinant P. Okay, so this is mean by the question hence. Hence means you need to use the information you get before this. So you cannot recalculate everything. Okay, so this is the way we answer the questions. And then for this part 2, this is one concept. When we multiply a row by a k, our determinant need to times 2, right? So we have 3 rows. So we have 2 to the power of 3 because times 2 times 2 times 2 for every row of it. And then another concept is determinant of A transpose equals to determinant of A. Then we get to the answer. Okay, so we continue. Number 3, we're going to find the adjoint. So adjoint, before I get to adjoint, I have to get to cofactor first, because adjoint is cofactor transpose. So we get to find cofactor. So number 3, by finding cofactor A. So cofactor A is a big bracket because inside here I have to find out every cofactor where positive, negative, positive, then negative, positive, negative, and then positive, negative, positive. Find out cofactor. Then only we can find out our adjoint. So we're going to do our row by row. 3, 7, 1, 3. This one I can copy from the determinant because determinant from here I'm using row 1. So I can refer back on my minor. What's in minor? So if row 2, then I have to cancel row 2. 2, 1. It will remain here 4, 1, 1, 3. 4, 1, 1, 3. So copy paste in out. So what is vertical? Then I close 4, 1. So the vertical is 2, 2. So we repeat again for row 3. So row 3. So it will be 4, 1, 3, 7. 4, 1, 3, 7. Copy paste in out. The vertical part here, which you think cancel is 2, 4, right? Just now I terpadam. 2, 4. Okay, so get to the answer. Okay, so 6 minus 2, 4. Okay, do your AB minus BC, 2 minus 6, 2 minus 8, negative 6, negative become positive. Okay, this one, 28 minus 3, 25. This one, 14 minus 4, 10. In front got negative. Here, 6 minus 16, so negative 10. So this is our cofactor. Then we can manage to get our adjoint, which is cofactor transpose. So write the row in column. And hence, what else the question asks us to do? And hence, obtain A inverse, find out X, Y, Z. So find out X, Y, Z here. So using this A. So we're going to find out what is our A inverse, where our A inverse will equals to determinant of 10, determinant of A, which is 10, we already found, so we cannot recalculate it here because determinant we found it in part A, we have to reuse everything we have. Then put in our adjoint. Make sure you do the multiplication inside, don't leave the value out there, and simplify. Finally, we solve our equation, where our equation is AX equals to B, right? So when I want to find X, I will time A inverse inside, time in front of the matrices so that I can get to the X. Because when we get identity, I can get to the X. So from here we can get the answer by multiply our A inverse with B. Okay, so this is unknown X, Y, Z here. Put in our matrix. Our matrix unknown, X, Y, Z. Our matrix inverse, which is this. Our matrix B, put in. So from here we can read out our answer. X is 10, and then Y is 13, and then Z is 5. Okay, so we're going to finish it. Our cofactor here we get 1 marks. Then only we get to the transpose. We do the transpose, and for the answer, adjoint. Then this is our inverse, and finding out our value matrix X, Y, Z. So total is 6. Yes, total is 6.